Assalamualaikum warahmatullahi wabarakatuh, and a very good day to my beloved panel, Dr. Haslinah binti Muhammad Nasir and TS Dr. Muhammad Syafiq bin Mispan. I hope you are all healthy and safe during this pandemic and stay at home. My name is Mohamad Aiman bin ABDUL Latef, and I major in Bachelor Electronic Engineering Technology in University Technical Malaysia Melaka. Today, I would like to present my Bachelor Degree Project 1 entitled Development of Epileptic Seizure Detection based on EEG signal analysis using MATLAB. Firstly, on project description, this project is basically developing algorithm for EEG epilepsy recognition system by using artificial neural network. This is to classify between healthy individual and epilepsy patient by evaluating their EEG data. Next, this project also used raw dataset from Department of Epilepsy, University of Bonn, Germany. This raw dataset then used for training, validation, and testing by using MATLAB Neural Network Toolbox. Furthermore, this project system invent to execute a process like a human brain to recreate the way human brain thinks. Next, for introduction of this project, epilepsy is brain-related disorder affecting the entire brain nerve system, and this caused by abnormal brain electrical activity, which is called as a seizure. Seizure can cause unconsciousness as a body shaking and many more brain-related issues. 5-row dataset which contain of 5 labels as A, B, C, D, and E. One set data contain 100 type of text file which consists of 4097 sample of EEG time series. Basically, set A denote as subset Z, which is healthy person during eye open. Subset B denote as subset O, which is healthy person during eye close. Set C denote as subset N, which is epileptic patient, while set D denote as subset F, which is epilepsy zone before seizure, and lastly, set E denote as subset S, which is in a region of seizure activity. Then the dataset of DWT be used for training, validation, and testing by using artificial neural network recognition system. After that, it will categorize the output data to which set it belongs, either normal or epilepsy. Okay, next, objective of this project. Okay, firstly, to develop epileptic seizure detection based on EEG signal analysis using MATLAB. So the detection is developed by using EEG data from University of Bonn. Secondly, to identify which sort of wave should be utilized. Okay, for example, standard deviation, power spectrum, or wavelet energy. So from that wave, we can investigate epileptic seizures detection and obtain the optimal result for usage with a neural network. And lastly, to develop a system capable of reading directly from an EEG sensor to a computer in order to detect normal or epileptic seizure. So for this one, before this, they use Arduino to connect with the sensor. Then for me, I will try to develop a system that can directly connect from EEG sensor, which is brain sensor, to the computer. Okay, for problem statement. Firstly, epilepsy patient constantly getting seizure without having to know when and how it might happen. But with the help of EEG, artificial pattern of brain activity changes when seizure happen can be seen on EEG reading. EEG signal have to examine the neural disturbance that has happened because of epilepsy. The EEG record consists of a large number of hours day detail and make it complicated cause data with large number of epileptic patients admitted to the hospital. This is require a huge number of data need to be recorded. Therefore, this method need to be optimized strongly. The suitable epileptic seizure detection in EEG signal based on DWT can be used to analyze EEG signal at very different subband and classify it using artificial neural network. The existing method used such as feed-forward neural network can be compared with cascade-forward neural network to compare whether the system able to classify successfully. Lastly, the data is raw, complex, and plain, which require analysis algorithm for accurate measurement. Basically, neurophysiologists or neuroclinicians have never been visual inspected EEG recording for epilepsy in identification method. It will obstruct the diagnosis process and often take several or more of EEG recording process. Besides that, they need a system because both huge amount and expanded use of long-term EEG record for effective neurological disease assessment and treatment according epilepsy. It also narrow the ability of experts to misread the data and fail to make a prepared decision. Plus, they also need to make sure that data is correctly taken and calculated, which is hard and compared to visual data, including testing the data. Okay, for methodology, from start, raw data that obtained from University of Bonn is processed in MATLAB. Then the system is processed by using DWT method. We will attempt to obtain coefficient outcome using standard deviation wave because standard deviation provide the greatest categorization based on the literature review. So following that, we will experiment with another wave such as power spectrum and wavelet energy to compare the accuracy result in confusion metric. After that, after completing process the data, input target will load for training validation by using artificial neural network. Then, with the using of wine classification, confusion metric will be plotted. For the preliminary result, we initially employ the cascade-forward neural network. The system used standard deviation as input data to assess its accuracy using a confusion metric. In this scenario, the number of neurons is increased from 15 to 20 in order to monitor and analyze the best result that the system can provide. And based on the first result, the confusion metric of 15 hidden neuron used show the overall accuracy is 73.1%, with all set during training, validation, and test give 73.1%, 69.3%, and 77%. While the result of 20 hidden neural network show the overall accuracy is 76.2%, with all set during training, validation, and test give 75.1%, 78.7%, and 78.4%. Okay, next, expected result. So, when the system is ready, a graphical user interface or GUI will display, as shown in the image. The best approach from the wave list that we try will be implemented to the system. GUI in the figure show the signal of person either normal or epileptic, and LED will light up according to the patient state. For the conclusion, EEG signals are brainwave generated in the human brain that represent the various tasks. Pupils react differently to a position depending on the status of signal generated in the nerve. The goal is to create a system that can read directly from the sensor to the computer to detect normal or epilepsy and display it using simple graphical user interface using MATLAB. Following that, another method such as power spectrum and wavelet energy will be used to read and analyze EEG signal using data from the University of Bonn. Then the result can be compared to determine which is the best result.